Okay, we just finished our study of the Haynesville Shale, and we concentrated on activity and well performance. So let's go ahead and get right in. All right, the first map I'm going to show is of Northwest Louisiana and East Texas, and the rig symbol shows the currently active drilling rigs in the Haynesville Shale. There's 41 rigs currently drilling. The most active counties are Caddo, DeSoto in Louisiana, and then in Texas, it's Harrison County and Angelina County. All right, so on the left, I have the top most active counties highlighted in red. So DeSoto has 8, followed by Caddo has 7. Then it goes down to 6. All right, then the bottom left, I'm showing the most active drilling contractors. Highlighted in red are the top ones: Patterson, Cactus Drilling, and Hemlick and Payne. Patterson has 8 rigs running. All right, the most active operators are shown on the right in red. Atheon has 9 rigs currently drilling, followed by Chesapeake, Southwestern, and Comstock Resources. All right, this map shows production wells that have produced over the last 15 years, color-coded by operator. Haynesville Shale wells and Chesapeake, Southwestern, and Atheon are the biggest, most active operators. We've had over 6,000 completions to date, and they cover 18 counties and parishes. All right, this map shows the play area. So the green line is the boundaries of the Haynesville Shale formation, which is the main target of this development. But the blue highlighted area is the Bossier Shale. Now, it's on the southeast corner of the field, and it's a little bit shallower than the Haynesville, but it is being developed at the same time as the Haynesville Shale play. All right, this map is from New Tech. It's a gas in place per section based on well log analysis. So the dark yellow colors show where the high gas in place is, and these are 140 BCF per section. And the lighter colors are the lower amount of gas in place. For example, on the southwest area, there's 70 BCF per section down there. All right, let's look at a schematic of how the wells are laid out with a type log on the right. So a lot of the development of the Haynesville is called stacked laterals. Now, stacked laterals are when you drill 2 or more wells closely together at the surface, but you complete them in different formations. So, for instance, the blue laterals are the Bossier, and you can see on the right the log where the Bossier is with the blue star. And then the other wells are drilled in the red that show the Haynesville. So this is called stacked lateral development. All right, this map here is color-coded by the landing zone of each well. So the wells that are landed in the Haynesville are colored red. The ones that are in the Bossier are colored blue. And this is from Drilling Info. It's their interpretation of where the wells were landed. All right. Now we have a picture of a typical multi-well pad in the Haynesville. So you have 4 wells all closely drilled together, and this saves space. You don't have to clear out as much surface area. You can have the wells close together. You don't have to move the rigs really far to drill them. You can have the equipment there. It gives some economies of scale. It's easier to treat all the wells when they're closer together. Okay, here's a 15-year graph of new wells drilled each year. So each bar represents a year. With 2023, we had partial data, but we estimated it for the full year. So you can see the play started in 2008. It ramped up immediately in 2010 and 11 with over 1,000 wells drilled. And then it dropped on off, bottoming out in 2016. And then currently it looks like we're leveled out at about 500 new wells drilled per year. Okay, this graph shows the history of the play in regards to new wells drilled in black and average gas price in red. So the annual average gas price is in red with the scale to the right. The black dots are the new wells drilled each year. So just trying to get an idea if the price fluctuation is driving the development. It doesn't seem to correlate with prices. But anyway, that gives you a flavor for how the prices have been changing over the years. All right, here's a rate versus time plot of the whole history of the field. The red is the gas production rate in BCF per day. And right now we're producing about 14.9 BCF a day from the field of all the wells. And there are about 5,600 active wells shown in black. To date, the field has produced over 34 trillion cubic feet of gas. So it's a very prolific field and very important for the country. All right, this chart has the years across the top and the parishes or county on the left, ranked from highest to lowest amount of wells drilled. So DeSoto is by far the most active drilled county or parish with over 2,100 wells. And then you can see the other counties when the wells were drilled and how the development pace changes in each area. All right, let's look at how the wells are laid out. This is DeSoto Parish in Louisiana. It's one of the big developed areas. And we have red wells shown in, the red wells are the Haynesville lateral locations. And the blue are the Bossier Shale lateral locations. So what we can immediately notice is that all the wells are oriented perfectly north-south. Looks like there's about 8 wells per section when they're originally drilling the 5,000-foot laterals. Here's the 5,000-foot laterals here. We have some 7,500-foot laterals as they're getting longer. The wells appear to be about 750 feet apart. And then even in some areas now we're going to 10,000-foot laterals. All right, let's look at Texas. Panola County, here's a map of Panola County. It's one of the active counties in Texas. Again, red are the Haynesville laterals and the blue are the Bossier. So immediately you can notice that the orientation of the wells are different. They're northwest to southeast, and that's due to the geology and the stress in the formations changes in this part of the state. So it looks like we have about 7,000 foot of spacing here in Panola. We have some 7,500 foot laterals and some 5,000 foot laterals. All right, to do our analysis, we use a technique called type curve analysis. So what we do is we take a group of wells and we normalize their production. So this is a rate versus time plot with the normalized gas production in red. So we can analyze a group of wells to get their average performance. So we have the normalized performance shown in red, and then we fit a curve through it that extends over to the right, as you can see. So this allows us to estimate the initial production rate for this group of wells on average, each well, and the EUR or reserves per well. And then we can capture the decline rate and the B factor that we're using. And then we also capture the average lateral length and proppant concentration for this group of wells, because we're going to normalize the data based on those parameters. All right, here's another group of Haynesville wells, but these are from 2019 to 22, so these are more recent wells. Again, the normalized gas rate is in red on the left. This is a rate versus time plot. And then we fit a curve through the data and extend it over to the right for this group of wells. So this allows us to get the initial production for these wells with their reserves and B factor and their proppant concentration. We take the average of all the wells in the sample and their lateral length. All right, this chart shows Haynesville and Bossier targets. So during the year, some of the wells are targeting the Bossier and some of the Haynesville. This is from Drilling Info. It just shows over the years how it changes a little bit, but basically 78% of the wells target the Haynesville. It's the main part of the play. Okay, here's a 15-year graph of lateral length. So each bar represents the average lateral length for that year. So we started out in 2008 drilling 4,000 foot laterals. And then we just keep going up and up over time to longer and longer laterals. But it looks like this last year, it might have leveled out at about 9,000 feet average. Okay, here's a 15-year graph of proppant concentration in pounds per foot. The gray bars show the average for each year. And it looks like, for the first 10 years or so, proppant concentration just kept going up. But it may be leveling out here in the last few years. And because proppant is expensive, you need to make sure you're getting more reserves as you add more proppant, to make it economic. So we'll investigate that a little bit here. But first, let's look at initial production rate. This is a 15-year graph of initial production rate. And the wells came in earlier, 8 or 9,000 or 8 or 9 million cubic feet a day. They keep going up. Over time, the rates are getting better and better, but it looks like in the last year, the rates have dropped off. So there could be a little variation. It could be, we need to watch that to see how that trend continues. All right, here's the 15-year graph of reserves per well, or EUR per well. So the black dots are the average. We started out under 5 billion or 5,000 MMCF per well. And the production and the reserves go up. But it looks like the reserves per well have leveled out. So it looks like the reserves per well have leveled out. 2023 looks like it's down a little bit, but because we didn't have a lot of data to do our decline projection and curve fitting on the last year, so that is a little subjective. There's a little subjectivity to how we estimate that. So maybe, the reserves, if we get more data for this year's wells, it might not be as bad. Okay, let's look at proppant concentration. This is pounds per foot on the left with all the shale plays in the United States: Barnett, Delaware, Eagle Ford, Midland Basin, Utica, and Haynesville on the right. So this is the last 12 months of what they're actually pumping in the wells. So it's easily shown that the Haynesville is the highest by far, most proppant concentration. Okay, here's a special graph. This is invented by one of my associate engineers, James Mumont. And what we do is we plot the reserves normalized by lateral length on the left and proppant concentration on the bottom scale. So the black dots are the average reserves per lateral length and proppant concentration for each year. So we got all the 15 years. You can see that as you add more proppant, the reserves per foot go up. So it's a pretty good trend. But this last year, in 2023, it looks like maybe the reserves are dropping off. So we have to watch that a little closer. But, if the reserves don't keep going up, it's no use pumping more proppant. All right, here's a similar plot, but it's for the initial production rate per lateral length, normalized for length of lateral, and proppant concentration again on the bottom scale. Here the well averages per year. It looks like the rates are going up as you add more proppant, but in 2023, it seems to have dropped off. Now that might be because all the good locations have been drilled, maybe. So now they're not drilling in the better areas. So that trend shows that maybe the rates are dropping off on new wells. All right, let's look at, let me go back. Okay, let's look at well performance for the top counties. And this is based on the number of wells drilled in the last 5 years. This is 5 years of performance. So DeSoto has the most wells drilled in it. And you can see their rate, reserves, lateral length, and proppant all averaged up for the last 5 years. But Red River comes out as the highest rate in reserve county, a parish. Okay, this is a graph of drilling pace for each county or parish, and it just shows you how over the years versus time that in some counties the amount of wells drilled picks up or drops. So it just shows you how development is changing from one county or parish to the next. All right. Okay, so again, we use normalized curves. Here's a 5-year normalized graph for DeSoto Parish. We have the normalized gas production in MCF per day on the left, and we put a line through it so we can capture what the average initial rate and reserves are for DeSoto. We can do it on Cattle Parish. We have the normalized curve with the projection to the right. And then we looked at Red River Parish. So this is the type of analysis we did with rate and reserves for those group of wells. Panola County. We can look at Harris County, put a decline through it. And St. Augustine County. All right, let's look at the most active operators. Now this chart is ranked by the highest current production. So Aethon is producing 2.6 BCF per day or 2667 MMCF per day. It's the highest production. This also shows how many wells they operate, each operator operates, how many are active, and what their cumulative production to date of the field, of all their wells in the field. Okay, Chesapeake has the most active wells, but they don't have the highest current production. As far as production per well, Trinity, their wells are averaging 6 million a day. So they have the highest current rates. All right, let's look at their performance of the top operators. This is 5 years of data, last 5 years. We have the wells sorted by the highest amount of well count. Aethon has the most, followed by Southwestern and Chesapeake. You can see their initial rates, their reserves per well, proppant, and lateral length. So Southwestern, over the last 5 years, they've had the highest production rates for their initial production rates for their wells. But BP has the most reserves per well at 15 BCF. But Aethon is pumping the most proppant. So they have the most proppant, but they're not getting the most reserves or rate. All right, so here's a type curve for the last 5 years. Aethon operated wells, Southwestern operated wells, Chesapeake have their normalized curve with our projection towards the right to get the EUR. Comstock is a big operator. Rockcliffe is another major operator in the area. BP. All right, here's a graph of a refrac example. So as we were going through some of the production plots, we noticed the rate jumping up. This is a refrac. So you can see this well is going to get incremental reserves from refracking. This is an example of an earlier well, 2013, operated by Exco in DeSoto Parish, Louisiana. It came on at about 10 million a day, and it's going to make, as shown in the bottom right, 3.6 BCF over its life. All right, here's an example of a high rate well, good well. Came in at 30 million a day. It's operated by Chesapeake. It's in DeSoto Parish, Louisiana. We made a projection through the data to the right, and on the bottom right, our EUR is 22.8 BCF. That's what we're estimating this well will make. So it's a very good well. Another example of a good well is operated by Comstock Oil and Gas. It's in DeSoto Parish, Louisiana. Came in at about 20 million a day. We went ahead and put a decline through its history. And the bottom right shows that this well will make 21.3 BCF. So that's a pretty good well. Here's another good example. This is by Southwestern. It's in DeSoto Parish. It was drilled in 2017. Came in on it at about 22 million a day. Its EUR is about 18.9. And there's the decline parameters that we use to project it. And again, 19 BCF shown on the bottom right. So it's a pretty good well drilled by Southwestern. All right. So they're drilling out a lot of wells out here, so they must be making a lot of money on them. So let's look at new well economics. So to do that, we had to make some assumptions. So we generated a type curve for all the new wells coming on in 2023. And that's about 12.5 to 13 BCF EUR is the type curve that we came up with. We're going to assume 100% working interest, 80% revenue. And we're going to use November NYMEX prices. with the well being drilled late this year, coming on in February of 2024. This is going to be the average lateral of about 9,000 feet. That's what they're currently drilling. So our data shows the drill and complete cost for this type of well should be about $13.2 million. We had some data on operating expense. It's pretty high at the beginning as they're flowing back all the fluids and everything. So we modeled it with $40,000 a month dropping to $10,000 a month over the several years, plus the 25 cents per MCF for transportation. So we made these assumptions and we put it into the economic program to see what a new well would look like. All right, so here is the economic projection for a new well. So we have the years here on the left. We have the gross amount of gas that we project from the type curve. We have the investments of $13.2 million here modeled in. And then on the right, we have the discounted cash flow at 10% discount rate, and it gives us a net present value of $6.4 million. Reserves are about 12.2. The economic reserves are about 12.2 BCF. The economic parameters are here. We have a return on investment of about 2 to 1, about 2-year payout. The internal rate of return is about 39%. So these are very good wells. They make good money. That's why they're drilling, and they have 41 rigs running. Now, I hope this was interesting and gave you some information about the play. We enjoyed putting it together. Please contact us if you want any of the data or you have any questions. And just thank you for listening and hope you enjoyed it.